Okay, so as we start this next little bit about writing an equation from a graph, a couple things you want to think about. I have the graph of y equals 1 over x, which is one of the toolkit functions. What happens with that is as x approaches 0 from the left, y goes down to negative infinity, right? And as x approaches 0 from the right, y approaches positive infinity. And that's when this is true for anytime this is an odd power. Even if we had 1 over x cubed, there'd be some things going on, but we'd still get the same kind of action going. When we have the reciprocal function, squared, when y equals 1 over x squared, all those values are squared, and we get this kind of action going on. Okay, where as x approaches 0 from the left, y approaches positive infinity. As x approaches 0 from the right, y approaches positive infinity. So they're heading off in the same direction. And we want to keep this in mind when we're trying to come up with equations for these kind of graphs, okay, these rational functions. Okay, so here's an equation. I see one thing I want to note is that, and I was too lazy to change this, these vertical asymptotes aren't really part of the graph. They should be dotted. Okay, one thing to and then that's idea I just talked about, how as I'm approaching this asymptote from the left, that's headed to negative infinity. As I'm approaching it from the right, that's headed to positive infinity. If I go to this side, I'm getting the same kind of action going on here. So this is like, actually this is almost like the negative 1 over x, right? So that I'm not sure if that comes into play here. It's just something I noticed, but let's see what we can do here. So I know there's a vertical asymptote at x equals negative 1 and at x equals 2. So keeping track what we know about the denominators, that should be x plus 1, and that should be x minus 2. Since these are acting like 1 over x in both cases, I can leave those to the single first power. I also see that this graph crosses the x-axis at x equals negative 4, and it crosses the x-axis at x equals 3. So those are the zeros, x plus 4 and x minus 3. And if I tried to graph this right now, I probably wouldn't get the exact same thing. There's probably some kind of stretch factor going on that they talk about in the book. So I'm seeing this point right here, that y-intercept is 0, 3. So there's probably some kind of factor, stretch factor as the textbook calls it, that's happening right there. And so what we'll do is let's substitute in 0 and 3 into this equation and see what we can get for y. For a. So 3 equals some factor times 4 times negative 3 over 1, because 0 plus 1, times negative 2. Negatives cancel out. 2 goes into 4 twice. So that's going to leave me 3 equals a times 6. Divide both sides by 6. I'm thinking a is 1/2. Okay. So I could write the 1/2 here. That would be kind of awkward though. I could write the 1/2 in front. Again, that'd be hard to type in. So what I'm going to choose to do is write y equals, or f of x equals over 2, and the 1 we don't have to write. So if we graph this, and I think I already did, I'm seeing that graph right here. I'm seeing the zeros. I'm seeing the y-intercept. I'm getting the correct behavior. I think I got that graph right. Alrighty. This graph. So what I'm noticing is I'm noticing a vertical asymptote at x equals -3. I'm noticing a vertical asymptote at x equals +3, I believe. Could be somewhere in between 3 and not 4. I'm going to guess it's 3 and it's just stretched. The other thing I'm noticing is that this graph is acting like the reciprocal squared function, right? Same thing there if you pretend that it's heading up in the same direction on both sides of it. So what I'm going to try to do for this is I'm going to try squaring each of those denominator factors. Whoops, let me get a pen. Okay, so I'm going to write x +3, and I'm going to square it to get that behavior going on. The same thing over here. I'm going to write x -3 and square it to get that reciprocal squared behavior. I'm trying to get that behavior acting at each of those asymptotes. I'm also seeing a 0 at x equals -1, so that would be a factor of x plus 1 in the numerator. I'm also seeing a 0 at x equals 2, and as we did in polynomials, it looks like it bounces there. So I'm going to write x minus 2 squared. Probably some kind of stretch factor going on. So let's try using that 0.01 and seeing what we get for a. So 1 is equal to a times 0 plus 1 times 4, because 0 minus 2 is -2 squared is 4, over 3 squared is 9, times 9, so that's going to give me 1 equals a times 4 over 81. If I multiply by the reciprocal, a should be equal to 81 over 4. So what I can do is write my function like this. So what I took two different screenshots of the same graph. What I wanted to see is that I'm getting this behavior going on here. It's going down. I'm getting that behavior at the other asymptotes. That's promising. I'm seeing my 0 at -1. I'm seeing my double 0 at 2, and I'm seeing the y-intercept at 0, 1. So I think that is the graph of that equation.